Today, we're going to make this cool animated 80s sunset pattern. Let's go. You might think by looking at this animated pattern that it's complex to make. But if we look at the graph that's generating it, it's actually pretty simple. If you've been following along with the series so far, you've made all of the nodes that you need, except for two. This perspective node and this bars node. So today we're going to work on making these two nodes, the perspective node and the bars node, and then we're going to assemble this cool 80s sunset animated pattern. So I'm going to show you how to combine the nodes that we've created in our node library so far to make this cool animated 80s sunset effect. If you haven't been following along, I'll post the link to the whole playlist down below so that you can catch up. We're going to start out in Unity today, and then we'll switch over to Unreal and build this there as well. So the first thing that we're going to do is make this perspective node. This node warps UV coordinates to make them look like they're receding into the distance. Just like you can see here, where our grid pattern is receding into the distance. That's being done by the perspective node. So let's jump in and build it. All right, so I'm going to come down here to my procedural library, and I'll go into my UV folder, and I'm going to right click and pick Create Shader Graph Subgraph, and we're going to call this Perspective. And we'll open it up and get started. All right, the first thing that I need to do is bring in my UV coordinates. And I want to use these UV coordinates only if we're not using the UV parameter. So I'm going to add a vector2 UV parameter. And in my graph inspector, I'm going to check this use custom binding box. And for the label, I'm going to type UV0. So now I'll bring in my UV parameter here, and we'll add a branch on input connection node. And what this is going to do is allow me to use the default UV coordinates if there's nothing attached to my UV input socket. All right, so there are my UVs. The next thing that I need to do is add some rotation. So I'm going to add a rotate node and connect up my UVs to the UV input of the rotation. And now I need to give myself another parameter here. And this is going to be a float parameter, and I'm going to call it skew rotation. And we're going to leave it as a default value of 0, and I'm going to bring it in. Now this value is going to be in degrees, and it's going to determine the direction that my perspective warp is happening in. So I'm going to plug this into the rotation amount, and we're going to set it, instead of radians, I'm going to set my rotation to be in degrees. So now I can type a value in here, and it will rotate my UV coordinates in degrees. All right, now we're going to expand the range of the value coming out of the rotate node. I'm going to multiply by 2 and subtract 1. And this is going to make it so that my range goes all the way around from negative to positive. That's what this multiply by 2 and subtract 1 does. And then I'm going to split out my UVs because I only actually want the U. I don't want the V. I just want the red channel coming out of here. And then we're going to lerp this red channel between a value of 1 and the value coming out of here. And the value that we're going to use for our lerp is going to be the amount of skew we're going to apply. So I'm going to add another float parameter and call this skew. And we're going to default our skew parameter to 0.4. That'll be the default amount that we're perspective warping the UVs that are coming in. All right, so now I'm going to take my UVs over here, and we need to add a scale node. So here under procedural UV scale, this is one of the nodes that we've generated in a previous video. And if you want to know which video and where in that video, look down in the description. Starting with this video today, because we have so many nodes that we've created so far in the library, I'm going to create a list down in there in the description that tells which video each of these were created in, and maybe even a timestamp so you can just jump right to it. We're making quite a large library that's going to end up having probably over 50 nodes in it. And I want to make sure that when I add a node like this, like scale, if you haven't seen the previous videos, you can just find scale in that list and click the link, and it'll take you right to the place where we created scale. Now, obviously, I'd prefer that you follow along and build your own library. But if all you want to do is create the 80 sunset pattern, then you need to know where to find how to create each of these nodes. So I'll help you out down in the description. All right, so I'm going to wire out the output here of our UV coordinates and plug that into scale. And then for the scale amount here, we're going to get that from our lerp node here. And so what this is doing is we've actually skewed our UV coordinates. Now it's kind of hard to tell that that's what's happening just from this. And so just temporarily, so we can see what's going on, let's add a procedural SDF rectangle node. So there's our procedurally generated rectangle pattern. And if we plug our UVs from here into there, now you can see that we've got a perspective warped rectangle. And that's what we're doing with these nodes here. All right, so we can just take this and plug it into our output. Actually, we need to format our output a little bit. Let's make this a vector 2, and we'll call it, we'll just call it out. And we can plug the UV coordinates into there that we've generated so far. Okay, the other thing that we want to do is create a mask. And let me explain to you why we need that mask. If we set our rectangle size to 1 here, so it's filling the whole view, and then we skew those UV coordinates, you can see that we've got this area here that's empty. And so what we want to do is find a cheap way to generate this mask that determines where our shape is and where our empty space is after it's been skewed. And the way that we're going to do that is we're going to generate a signed distance field, or an SDF. So I'm going to take my UV coordinates and I'm going to split them out, and we're going to measure whichever coordinate is the smallest. So between the U and the V, which one is smaller? And then we're going to do the same thing again, but this time I'm going to add a 1 minus node to kind of get the inverse. And I'm going to split this out and again find the minimum. And then between this regular minimum and this inverted minimum, I'm going to find whichever is the smallest among those. So the minimum of the 2 minimums. And now you can see the result that I've gotten there is a signed distance field. So the highest value is right here in the middle of my pattern. And then the values here are showing the distance to the center. And that out here we have 0, or maybe even something smaller than 0. All right, so in order to resolve this from a signed distance field into a shape, we're going to use an inverse lerp node, and we're going to plug our signed distance field into that. And now we have these 2 values here where we can control the size of the shape. So if I give this a 0 and this maybe a 0.01, there, now you can see that we've made a shape. But we want to be able to allow the users of this node to control this shape. And so I'm going to add 2 more parameters here. I'm going to add a float parameter called alpha threshold, and another float parameter called alpha feather. And this alpha feather value is going to allow you to create kind of soft edges on this. Here you can see we've got hard edges, but the higher we go with this value here, you can see our edges are starting to get soft. So that's what alpha feather does. So we're going to take alpha threshold and plug it into A. And then for alpha feather, we're going to give it a default value of 0.02. And then we're going to make the value that comes into our inverse lerp an addition. So we're going to add our alpha threshold together with our alpha feather and plug that in there. All right, so we've got our mask and we can plug this into our output as well. We just need to add another output parameter here and call it alpha, and we can output our result like that. And we did it. We've got our perspective warp node, and it's creating the UV coordinates for the perspective warp. And we also set it up so that it creates a mask that we can use to mask out our shape. Now, one thing that I did want to show is if we adjust our skew rotation, right now we're kind of warping to the left by default, but we can use this value here, the skew rotation, to determine which direction we're warping. So if I type 90, now we're warping down. If I type -90, we're warping up. And that's what we're going to use for the 80s sunset pattern. So we'll get back to that in a minute. But for now, we need to finish this off. So I'm going to double click here where it says subgraphs and type procedural/UV. And that's the category that this node is going to be in when I look for it in my create node menu here. And then the other thing that we need to do is come over here to graph settings and set our preview type to 2D. And we're done with this node. So the other node that we need is the bars node. So let's go ahead and get started on that one. I'm going to come up here to our patterns folder and right click and pick create shader graph subgraph, and we'll call this one bars. This is going to create a bars pattern for us, and we can determine how many bars we create. So there are two parameters we need. We need a vector2 called UV, and then we need a float parameter called bars, and this is the number of bars we're going to generate. By default, we're going to set the number of bars to 4, and like we always do, we're going to check this use custom binding box for our UVs and type UV0 for the label. All right, let's set up our UVs. So we want to branch on input connection node, and we'll plug our UV parameter into that, and then create a UV node to plug in here as well. And there are our UVs all set up and ready to go. Now we're going to multiply our UVs by the number of bars. So right now our UVs go from 0 to 3 horizontally, and also 0 to 3 vertically. And what we want to do is round them down to the nearest whole number. So I'm going to add a floor node, and that's going to round these values down. So here, vertically, we have 0 down here, 1 here, 2, and 3. And then we've got the same thing horizontally. And now I'm going to use a modulo node, and we're going to modulo this by 2. And here you can already see our bar pattern showing up. So we've got horizontal bars and we've got vertical bars. This is looking exactly like what we need. The last thing that we need to do is add an absolute node. And right now we've got both of our bars together, so we need to split these out. And here in the red channel, we have the vertical bars, and in the green channel, we have the horizontal bars. So for our outputs, we're going to change this to float and set it to call this one vertical, and add another one and call this one horizontal. And then we can plug this in from the red channel and the green channel, and we've got our bars. And if we use, let me just clean up the graph just a little bit here. If we use preview nodes, we can take a look at what this looks like. So these are our vertical bars, and these are our horizontal bars. And like I said, we can control how many bars there are here using this bars value. So make 8 bars or 12 bars, as many as we want. All right, so there's our bars subgraph. It's all done, except we need to put it in a category. So we're going to put it in procedural patterns, and we'll come over here to our graph settings and set its preview mode to 2D. All right, so we've completed our bars node and our perspective node, and we're ready to assemble our 80s sunset. So I'm going to come here to shaders. There's our lava lamp shader. Remember that one? That was fun to build. We'll right click here and pick create shader graph URP. And this is going to be a canvas shader, which means we can apply it to our UI. And I'm going to call this 80s sunset. All right, we'll open up our 80s sunset shader and we're ready to go to town. So the first thing that we need to do is bring in the perspective node that we created. This is going to generate the UV coordinates we're looking for. And the next thing that we want to do is create that animation. So I'm going to create a move node. And we're going to wire our perspective warped coordinates into the move node. Now on our perspective node, let's set a couple of these values. For our skew, we want it to be skewed at 0.9. We want our skew rotation to be -90. And we're going to leave the alpha threshold and alpha feather alone because we're actually not using the output value this time. All right, the next thing that we need to do is animate these. So I'm going to add a linear time node. And we're going to set our speed to 0.1 because we want that animated grid to be relatively slow. The next thing that we're going to do is add a vector 2 and plug this into the Y component of that vector 2. We only want it to animate on the Y axis and not the X. We're going to leave our X at 0. And then we're going to plug this into move. Now you can't really see it, but those UV coordinates are now animated. So the next thing that we need to do is actually use these UVs. And we're going to do that with a square tiles node. And this is the one that we created last week that generates that procedural tiling pattern. But if we plug these UV coordinates into it, it's going to generate a tiling pattern that looks like it's receding into the distance. Doesn't look that great right now because these previews are kind of low resolution, but in just a minute I'll show you the real preview and it'll look great. So let's make a couple of adjustments. We're going to set our tiles to 4 and 32. We're going to set our size to 0.93. And then we'll leave thickness and blur alone. So one issue here is that our grid is kind of aliased. And we're going to use our anti-aliasing node to fix that. So I'm going to come over here and add our anti-aliasing node. It's under Procedural Helpers Anti-Aliasing. And we'll plug our sign distance field of our grid into the gradient input. And we'll set our cutoff to 0. Now you can see our grid is starting to look a little bit better. But the resolution on our thumbnails here is still too low to be able to visualize. So let's take a look. If we just plug this into the base color input on our master stack and open our preview, now you can see we're starting to get a grid that looks pretty cool. But there's some really crazy stuff going on up here at the top. So let's fix that next. I'm just going to minimize this. Actually, I'll hide the preview for now. And that's what we need the bars node for. So I'm going to bring in bars. And we're going to use the bars node to mask off the top half of our grid. And the way that we're going to do that, we need a linear gradient node. And I'll plug the V coordinate of the linear gradient into the UVs. And then I'll take the horizontal bars coming out of here. We're going to set bars to 2. And now you can see we're getting the mask that we're looking for. And so the horizontal thing coming out of here, I'm going to add a multiply. And then we're going to multiply this by our anti-aliasing node result. And now you can see we've got black up here and a nice grid down here. So let's plug that into our base color. And if we open our preview here, now you can see we're generating a really cool looking grid with our sky up here and our ground down here. And our perspective warp is doing a great job of making that grid look like it's receding into the distance. Okay, the last thing that we need to do is add color to our grid. And that's really easy in Unity because we have this node called SampleGradient. And what I can do is click here on the gradient, and it brings up this really nice UI that allows me to create a gradient. And I've already created this one, and it looks like this. So I have a value here that's this color at 0. I have another value here that's this color at 13.2. Then this color at 49.9. This color at 56, at 75, 92.9, and then at 1 or 100%. So that's the gradient that I've created. And basically the way that I did this is I pulled up a reference image. I pulled up a reference image of an 80s sunset image that I found just on Google image search and just sampled the colors out of that gradient. So you can do the same thing. All right, so we'll take our gradient here. And from our linear gradient node coming out of here, we're going to create a 1- node and plug that into our gradient's time input. And now you can see we've got that great 80s sunset gradient that we needed. So now what I'm going to do is add a lerp node, and we're going to blend between our 80s sunset using this as our mask. So we'll plug our animated grid pattern here in. And now we have our nice pattern. We've got our sky gradient and we've got our ground gradient, but our grid pattern is black. And I think it would be nicer if it was kind of a dark pink color. And so I'm just going to paste in this other color value that I created, and we'll plug that in. And now we've got our nice 80s sunset pattern, and it's looking pretty cool. The last thing that I want to do is just juice it a little bit. And by that, I mean I want to increase the contrast on it, just so those colors pop a little bit. So I'm going to set my power to 2.2. And now I'm going to plug this into base color. And let's take a look at what our preview looks like. Bring up our preview, and wow. An 80s sunset in all its glory. That's fantastic. Like I said at the beginning, this was a pretty easy pattern to make because we had all of these nodes created and ready to go in our library. So I was able to just call on our library and grab all these nodes, linear time, perspective, move, square tiles, anti-aliasing. And it was really quick to bring all these nodes together and create something really cool just by using the building blocks that we've been creating so far in our library. And if you've been following along, you've got all these blocks and you're ready to go, and you can even wire them together and make your own cool procedural patterns. And I definitely encourage you to do that. All right, now let's switch over to Unreal, and I'll show you how to do the same thing in that engine. All right, so here we are in Unreal. And you can see that just like we did in Unity, we've pieced our nodes together and created our really cool looking 80s sunset pattern. This is the same shader that we just created in Unity, but now we're making it in Unreal. However, in Unreal, there is one problem, and I'm going to scroll up here and show you what that is. Unreal doesn't have a nice UI for generating gradients. And so what I had to do is make this SampleGradient node, and I'm going to show you how to make that in a minute, but this is doing the same thing that Unity was doing basically, but it's kind of a little bit more complicated because I have to create all these color nodes manually, create all these position nodes manually, and then also pass them into the SampleGradient node. But I'm going to show you how to do all that, so we're good. So what I'm going to do now is I'm going to show you how to create the perspective node. I'm going to show you how to create the bars node, and then we're going to wire all these nodes together to generate our 80s sunset pattern. All right, first let's take a look at the perspective node. We're going to start over here with our input UV. So I've named this input UV here, and I've set it to be a vector 2, and I check the use preview value box, And I plugged in the texture coordinate node here so that if our UV input is empty, it's going to use the default texture coordinates. All right, then I've created a custom rotator node, and this node ships with Unreal. So I just type custom rotator, and there it is. And I've plugged our input skew rotation into rotation angle. Now the input skew rotation here is a scalar value. I've defaulted it to 0, and I've checked the use preview value as default so that 0 value is what's being used. And I plugged that into the rotation angle. Then I took that rotated value and multiplied it by 2 and subtracted 1. And then we used a component mask to grab the red channel or the U coordinate. And we're using this linear interpolation node to blend between a value of 1 and the value that we calculated here, times 2 minus 1, U coordinate into the B of the lerp node. And then we're lerping between 1 and the value that we calculated here using the skew input. And you can see I've set the skew to be scalar, and I've set its default to be 0.4. All right, and then we take the UV coordinates that we brought in and we scale them with this scale node. Now this is one of the nodes that we've created in our node library previously. So if I open my content drawer here, come down here to UVs, there's the scale node that we created. So I plug our UVs into the scale node, and then the amount of scale that we're using is the value that we calculated here with these nodes. So then the result coming out of scale goes into our output, and we just call it out. So there are the warped or perspective warped UV coordinates that we generated with these nodes. And today, that's all we're going to use. But I wanted to make the node a little bit more useful. So I created these nodes down here that generate our alpha mask. And the way that works is we take the UV coordinates coming out of scale, and we split the U and the V, or in this case it says R and G for red and green, and we find the minimum of those two. And that looks something like this. And then we do the same thing, but this time with a 1 minus. We use a breakout float 2 components to split the red and the green. And we find the minimum of those two that looks like this. And then we add another minimum and find the minimum of the two minimums. And that looks like this. And what this is a signed distance field of the shape of the UV coordinates that we've generated. So now that we have our signed distance field, we need to resolve the shape using an inverse lerp. And so we plug our minimum value into the value input of our inverse lerp. And then we use two new inputs, alpha threshold and alpha feather. We're going to set alpha threshold to 0 by default and alpha feather to 0.02 by default. Then we'll plug our alpha threshold value into the inverse lerp A input, and we'll add our threshold and our feather together and plug them into the B. And that's going to generate the mask for where our UV coordinates are between 0 and 1. So anything outside this mask is black, and that's where our UV coordinates are either higher than 1 or lower than 0. So that's how we create the perspective node that warps our UV coordinates. All right, so we're going to use the perspective node in a minute when we create our cool 80s sunset pattern. But first, let's jump over and I'll show you how to create the bars node. So as you can see, our bars node is just generating alternating black and white bars. In this case, they look red, but that's just because it's just showing a single channel. So this is what our vertical bars look like and our horizontal bars. And this node is actually pretty simple. We have our input called UVs, and it's a vector 2. And we're using text coordinates as the default input. And then we have a scalar input called bars, and you can see we've defaulted it to 4. And as always, we want to check this use preview value as default. Then we multiply our two inputs together, and then we floor to round down to the nearest whole number. And then we're using the fmod node, and this is going to alternate between black and white for each of those bars. And we're make sure that you use a value of 2 for the B input for the fmod. Then we use absolute to get our final result, and then we split up our channels. The red channel is our vertical bars, and the green channel is our horizontal bars. And that's how we generate the bars pattern node. So we'll save that. And now let's make a brand new shader, and I'll show you how to use all the nodes that we've created so far to generate our 80s sunset pattern. So I'm going to come down here to our content drawer and come to shaders. Here's the one that's already done, but we're going to build one from scratch so that I can show you how to do it step by step. So I'm going to create a material, and we'll call this 80s sunset, and we'll open it up. Now the first thing that I'm going to do, just to make this a little bit easier, is I'm going to set my material domain to user interface. And what that's going to do is it's going to change my preview here so that I can see user interfaces a little bit better. So let's just open this up so it's a nice big size so that we'll be able to see our result there. Okay, the first thing that I need to do is we just created a perspective node that warps UV coordinates. So I'm going to bring in that node. And there's a couple of values that we need to set. The first one that I'm going to set is the skew value. I'm going to set skew to 0.9 so that we're getting almost the maximum amount of perspective warping. And then I'm going to set the rotation to 0.75. And this is going to make our UVs warp from the bottom toward the horizon. So now if I plug this in, you're going to see our UV coordinates over here. That's what we're generating. And eventually we're going to use these on our procedural grid. But the first thing, before we do that, we need to actually animate them. So we're going to bring in our linear time node. Here's our time folder. There's our linear time node. And I'm going to set the speed of linear time to -0.1. And now I'm going to create a 0 node here, and we're going to create an append vector node. And we want the 0 to be in A, and we want the loop of our linear time to be in B. This is going to animate just the Y component of our grid and not the X. So the next thing that I need is a move node. So I'm going to come down here to our UV folder and grab a move. And we're going to plug our UV coordinates into that. And then this is our animation going on here. So we're animating on the V and not the U. So let's plug these in. And you can't really tell what's going on. I mean, you might be able to see this moving just a little bit. But what we need to actually see what's happening here is the square tiles node that we created last week. So I'll come here to our patterns folder and grab our square tiles node. And we're going to plug our UV coordinates into that. And then we also need to set up a couple of these other values. So for tiles, I'm going to set our tiles to 4 and 32. And then for size, I'm going to set this to 0.93 and 0.93. And we'll plug that value in as well. And now let's see what we're getting for our grid. Oh, look at that. That's really cool. So down here at the bottom, we're getting decent results. But up here on the top half, we're getting something really weird. So we need to fix this weirdness on the top half. We're just going to mask that out. And then down here on the bottom, it's a little bit too aliased. And so we're going to use our anti-aliasing node to fix that as well. So let's go ahead and come over here to our helpers folder, and we'll grab our anti-aliasing node. And from our SDF output on our square tiles node, we're going to plug that into our gradient. And then for the cutoff, we're going to set that value at 0. So let's plug that in. And now you can see we've got anti-aliasing, really nice anti-aliasing down here at the bottom, but the top is just going nuts. So let's just disconnect this for now, just so we don't have to stare at that. And let's fix that top. We're going to fix it with the bars node that we created. So I'm going to come over here to pattern and bring in our bars node. And we're also going to come over here and, oh, actually, this one's in the library. This is the linear gradient node. And we're going to use our linear gradient V gradient as the UV coordinate to create our bars. So if we preview this node, you can see that we've got our nice bars pattern there. And for the number of bars, we actually just want 2 instead of 4. So now you can see we've created this really nice mask. And we can use this mask to mask out that craziness that we had at the top of our grid pattern. So I'm going to take our bars and we're going to multiply the output of that by the output of our anti-aliasing. And if we then start previewing this, now we've got our great grid down here at the top, at the bottom, and nothing up here at the top, which is exactly what we were looking for. All right, so this animated pattern is what we were hoping to create, but the last thing that we need is a gradient. And in Unity, we had a node that was specifically designed for creating gradients, and we had a really nice UI for making those gradients. But we don't have that in Unreal. And so what I've done is I've created a gradient node manually, and I'm going to show you how to do that as well. So let's switch over to this material function, and I'll show you how it works. There is a lot going on here, and I apologize for that, but yeah, Unreal just doesn't have a slick way of doing this like Unity's shader graph does. And so we're just going to have to put up with the complexity of this solution, and I apologize for that. The first thing that I need to do, you can see that we've got the colors of our gradient coming in here, and we've got the placement of those colors coming in here, and then those values plug into this node right here called the gradient node. So let me first show you what's in this gradient node, and then I'll do a little bit more thorough job of explaining what's going on here. So if we switch over to this gradient node material function, you can see that we've got a gradient mask input. And by default, this input takes the texture coordinates and uses the horizontal texture coordinates here. If we take a look, you can see that our horizontal texture coordinates go from black over here to white over here. So that's what our default input is. So we take that input, and then we have our first position and our second position. By the way, the point of this node is to take our input mask and then take 2 positions and blend between those 2. So we're going to take our mask and we're going to subtract position 1. And then we're going to divide by 1 minus position 1. And then down here, we're going to take our position 2 and subtract position 1 from that. And then we're going to divide by 1 minus position 1. And then we're going to divide the result of both of these operations there, and then saturate the result and output. So this is like 1 unit of the gradient. We're going from one color to the next color. And we're going to do this operation multiple times, which is why I made it into a material function. So let's switch back to our sample gradient node that we've created here, and I'll show you what's happening here on a local scale, and then we'll zoom out and I'll show you what's happening kind of as a bigger picture. So there's the gradient node that I just showed you. This is that material function, and it's blending using the gradient mask, and position 1 and position 2. And then we use the output of that as the alpha to blend between our two colors. So here's color 1 and color 2. In this case, we're using values of red and yellow, but obviously you can set these to whatever you want. And you can see over here on our preview that that first little blend is happening from red over here on the left-hand side to yellow, which happens right about here. And the positions of those two colors are determined by these two input nodes. Oh, by the way, I've had some of you down in the comments absolutely begging me to use these named reroute nodes, and so I finally broke down and did it, just because this particular graph is pretty complicated. So you can see over here, the gradient mask named reroute node is jumping our input gradient mask, which defaults to the U coordinate. It's jumping that value over to here. So there's our gradient going into our gradient node. And then we're taking position 1 and position 2. So there is one unit of our gradient, and that's what's blending from red to yellow. And now we need to blend from that into our next color, which is green. So there's our next unit, and we've got our green input color. And so that blend is happening from yellow to green right there. So you can see I've got my next gradient node, and I'm blending from position 2 to position 3. And then for my cyan color, I'm blending from position 3 to position 4. And then from position 4 to position 5. And so on. So you can see that each of these little blend units... oh, by the way, I also have a lerp node here on the end. So my gradient node output is the alpha to blend between my two colors, in this case red and yellow. And then I'm taking the result of that and plugging it into the A of the lerp. And then the B of the lerp is the next color in the blend. And so on. So each of these units is doing one blend. And in this case, the gradient that I've set up has the option to do 8 different colors. But obviously you can set up as many of these as you want. Now, the more colors you're blending between, the more math you're doing, and the more expensive this gradient node is. And so you want to control this carefully. I know in my case, I need 8 colors, and so I've set up a gradient that blends between 8. But if you want to do a gradient with fewer colors, you probably want to create another node and delete some of these blend units so you're not doing as much math. But this is how it works. I guess the one thing that I haven't mentioned yet are these positions. So position 1 is 0. It defaults to that. Position 2 is 0.142857. And basically what I did to calculate these values is this value is 1 divided by 7, and then 1 divided by 7 times 2, and times 3, and times 4, etc. And so depending on how many colors you're going to blend, you want to divide 1 by that number of colors minus 1. So I knew I wanted to blend 8 colors, and so I divided 1 by 7 to get these incremental values here going up. And then, so the inputs come in here, and then we're using the named reroute nodes. So there's position 1, position 2, and those get jumped over to here with the named reroutes. All right, so this is kind of a lot to do to set up a gradient, but that's what we need to do to make things work in Unreal. So if I'm going to make that gradient in here, I need to go ahead and bring in that gradient node. So I'm going to come to my gradient folder and drag in my SampleGradient node. And now I need to plug in our gradient mask, and then all of the colors and all of the positions of those colors. So for my gradient mask, I can take my linear gradient, the V gradient here, and add a 1 minus. And I'm going to plug that into the gradient mask slot there. And now I need all my colors and all of my positions. And I've already got these worked out, so I'm just going to grab my color nodes from off screen and paste them in. There are all my colors. And yours don't have to be exactly the same, but if you want to copy these, you can pause the video here and like sample these values if you want. It might be cooler if you actually came up with your own colors for the gradient, but however you want to do that. So now I'm going to plug each of these color values in. Color 1, color 2, color 3, color 4, color 5, color 6, color 7, and color 8. All right, so we've got all our colors. Now we just need the positions of where those colors should be applied. And I've also got those, so I'm going to paste those in from off screen as well. So here are our positions. The first one is 0, that's position 0. 0.132 is position 2. 0.499 is position 3. Position 4 is 0.5. And by the way, between position 3 and 4, that's what creates that nice hard edge of the horizon. All right, the next one is 0.56, then 0.75, 0.929, and 1. And that creates my gradient. So if we take a look at the preview of that, we've got our beautiful 80s sunset gradient with a nice hard horizon there, going from purple to dark purple, and then a really pretty sunset sky there at the top. Okay, now I need to take this and we're going to add a linear interpolation node. And we're going to blend between our gradient color using the mask that we created down here. This is our animated grid. So if we plug this in, now you can see we've got white for our grid color there. And that's not exactly what we want. I think it would be better to have kind of a pink, a darker pink color for our animated grid. And so I'm going to copy and paste this color in from off screen as well. This is kind of our dark pink color, and we'll wire that into our lerp value. And now we have a grid that's that dark pink. And that's a little bit nicer looking. The last thing that I want to do is just increase our contrast. And so I'm going to add a power node, and we're going to set this to a power of 2.2 just to increase the contrast there and kind of juice the results. So now we've got our really cool looking 80s sunset. All right, you can see each of these blue nodes here, except for linear gradient that already existed in Unreal. All of these other blue nodes are nodes that we've used from the library that I've showed you how to make in this series. So if you've been following along, you have your own node library here of gradients, helpers, patterns, sign distance fields, time, and UVs. And all of these can be pieced together pretty quickly to create cool shaders like this. So I hope that you've been following along and creating this really nice library of nodes that you can use in the future when you want to create procedural shapes and patterns. All right, thanks for watching, everybody. I hope you enjoyed this video, and that even if you're not planning to use this 80s sunset pattern for anything, that you learned how to at least wire these nodes together to get the results that you're looking for, and that you can use these in your own projects to make what you're trying to create. All right, have a great week, everybody, and I hope to see you in next week's video.